Willkommen jetzt im großen Saal zur keynote. And I quickly now switch to English because this keynote will be in English, even so that we both from Germany. And but I'm very, very happy to have Johannes over here on stage, Johannes Schaback, and he is actually he's founder of Ladenzeile. He's CTO, and he's a real tech guy. And so maybe just to tell a little bit about his background. Johannes was studying computer science in Berlin, and so I think he was nearly doing his PhD in machine learning, right? I heard around 3 weeks, and then you stepped because you had a meeting with Zamver, and with the Zamver brothers, with Oliver Zamver, as far as I remember, and you were more coming from this computer science thing, and he was telling about online marketing, and you said, wow, this is really cool shit, online marketing, so maybe I do something in this area. And I think this is perfectly for us as an online SEO AdWords audience to have somebody who's technically orientated, but thinks that online marketing is really a cool thing. And I'm very happy to have Johannes over here, and please give Johannes a warm welcome.
Wow, thank you very much for having me. I'm still a little bit hangover from yesterday, so it's great that there are so many people. I'm really thrilled to be here. It's an honor, it's fantastic. I have to admit, you know, artificial intelligence is very much like teenage sex. You know, everybody talks about it, but nobody knows how to do it. Everybody thinks the others are doing it, so they claim I'm doing it as well. Right? Not just to look stupid. The truth is, it's actually an analogy that holds. I have the feeling that many of us, marketeers in particular, are very puzzled by the fact what artificial intelligence actually means and what it does and what it can do and what the differences are between machine learning, artificial intelligence, and deep learning, why Facebook, Google, Amazon, Apple, Shenzhen, etc. invest so much money in artificial intelligence. And some of these questions I'm trying to reveal today, and in the next 40 minutes, I hope I can give an answer on where we're heading with machine learning and artificial intelligence. So who am I? Alex actually kindly introduced me. So I am a nerd, it's true. I studied computer science. I'm a co-founder of Ladenzeile, an aggregator for fashion and furniture in particular, and we became a machine learning company pretty much without intent. It was a necessity for us. And so before I found Ladenzeile, I've been engaged with Axel Springer and Rocket Internet. And yes, it's true, I started a machine learning PhD for 3 months, though not 3 weeks. Right? That's a big difference. It's a huge difference, for me at least. Because I could not imagine myself that in 10 years, I would be looking at an explosion of artificial intelligence-enabled applications. Today, there is autonomous driving. There are numerous applications in healthcare. There is computer vision. There is speech recognition. There is natural language processing, natural language generation. There's numerous applications in all fields, in gaming, weather prediction, etc., you name it. And one particular gentleman put it very, very nice and neatly last year. Sundar Pichai, the CEO of Google, stood in front of his developer audience last year and said and rephrased that we are looking at a transition where the world is transferring from a mobile-first into an AI-first world. What does that mean? Well, first of all, it means that Google bets that the impact of AI will be as large as mobile was in the last decade. That's huge. And if we think that we have to have a piece in that, a part in that, a story in that, we need to be on alert. But not only Google invests heavily. So alone in 2016, there were 26 to 39 billion euros primarily from the tech giants invested into, not euros, dollars, excuse me, invested into artificial intelligence, 6 to 9 of which were in startups. And this trend continues. The deal size, in exits or in transactions actually increases. Last year, there was this huge mobile transaction, an Israel-based computer vision company that primarily focuses on autonomous driving, that had been sold to Intel for whopping $15 billion. And they only run a yearly revenue, to my knowledge, of a couple of $100 million. That's ridiculous, even for Silicon Valley standards when it comes to valuation metrics. But also the pace and the frequency increases of these transactions. There are equi-highs all over the place. I would drop out of university just to start a startup, in artificial intelligence. And it's a little overhyped, as I'd admit. And then, you would be acquired. Just these tech giants need you as the talent. But in order to understand where this hype is coming from, we need to go back. We have to do a slightly, not intuitive step in order to understand where this disruptive power of machine learning and artificial intelligence is coming from. And this is what it is. Defining intelligence is actually really, really difficult, but I'll give it a try. Because as a techie, you would say artificial intelligence, in its most general form, is basically a device that constantly perceives its environment and takes actions in order to improve the likelihood of reaching a goal. That sounds very nerdy, but in fact, it's beautiful. Because if you think of it, it's a function that receives an input vector x and outputs an output vector a, right? For example, if you want to train an artificial intelligence that does stock trading, right? You would feed it all the different historical data that you have about that particular stock that you're trading, plus additional market info, et cetera, et cetera. And then the function would output, the recommendation, or basically the answer would be whether you should sell or buy that stock. Or whether you could also train a different AI that classifies animals on images, basically. So you would present it different images, horses, tigers, lions, etc., and the AI would output and say, OK, that's a tiger on that particular image. Or you could present it structured data, such as tracking data, right? Or data from your keyword performance, right? Or any other sale data that you may have in your business. And the AI would train to either increase the bid price or lower the bid price, or whether you should raise the price of your products that you're selling. Or you could provide it, train a different AI, an audio signal, a wave-encoded speech signal, right? And the AI would detect and decode the signal into something meaningful, the word that's been spoken. So the big question now is, how do you do that? Well, the answer lies in learning. And to understand learning, we need to understand how humans learn. And that's actually interesting, because humans learn by experience. Right? We run against a wall, and then it hurts, obviously, and then we realize, oh man, I shouldn't run against walls, right? And I make an experience the next time I improve, right? Or if you have a kid, then you realize how they start walking, right? They make experience, fall down, get up again. With machines, it's entirely different. They're stupid. They follow a fixed set of instructions, like a pancake recipe, right? Eggs, butter, flour, steer, etc. Right? But it's very strict. And if you screw the order up, then the pancakes are ruined. So they're stupid. They follow instructions, but they got data. And if you bring both together, then you got machine learning. Machine learning are algorithms that learn from data. Now, what's the difference between machine learning and artificial intelligence again? Actually, it's kind of fuzzy. First of all, both are algorithms. And if we talk about algorithms, then we can draw nice bubbles of sets of algorithms. So AI, in the broadest sense, is just a huge set of accumulation of algorithms. It's pretty much everything that in the history of mankind people thought is cool stuff, so we call it AI, right? So in the 70s or in the 60s, AI is older than me, right? So it's a huge set of various different algorithms that somehow perceive their environment and take action upon that input and actually try to improve the likelihood of success. But within this huge fuzzy bubble of AI algorithms, there is one particular one that is machine learning. And these machine learning algorithms are those that improve upon being exposed to data. That's very important, whereas with the other algorithms may not improve on the go, right? Within machine learning, there are numerous algorithms such as support vector machines, Gaussian processes, et cetera, et cetera. If you study computer science, you'll have the fun of studying them all. And also artificial neural networks. And within artificial neural networks, there is a particular class of very large neural networks called deep learning. Deep learning is the reason for the hype. Deep learning is fueling the recent advancements in machine learning and artificial intelligence. Deep learning is the key to understanding machine learning. And this is how it works. First of all, artificial neural networks are pretty much modeled by their role model in the organic world. If you look at an organic neural network, then it's basically a network of neurons, right? Some of us have more, some of us have less, but the point is they have cores, they have axons, they have dendrites, and they're all like spread out in a network, and if there's a pulse going through the neuron, then it spreads it out and transmits the information on into the network. The key idea about neural networks in the artificial sense is to simulate exactly that. So what you do is you stack neurons in layers and have them connected to all the other layers, or to the next adjacent layer, actually, fully connected. Each neuron is connected to each neuron in the next layer, right? Then you would have parameters that if you would activate these neurons, they would pass on the information in a certain way all the way through the network. So let's say you want to classify, you want to decode handwritten digits. So what you would have is an image, a grayscale image in this case, of a handwritten 5, for example. As you know, images are just pixels, or rasterized pixels. So for each pixel, you get a grayscale value, and for each grayscale value of each pixel, you can correspond that to one neuron in your network. So you would map one pixel onto one neuron in your network. Then you would have the information being feed forward through the network, and at the very end, there's one neuron that stands for number 5, which then should fire such that you know, oh, there is a 5 on the image. This is how it works. If there is an error, let's say you're presented a 7, and it unfortunately outputs a 1, that's wrong, then you would feed back or backpropagate the error that's been made throughout the network, like tweak and tweet and tweet a little bit with the weights and the parameters of that network such that the next time you present a 7, it gets it right. So that's 2D, but you have to think of it in 3D, as a matter of fact, because if you think of images, then they are 2D, and if you stack them, it becomes kind of like a cube architecture. So what you see here is basically an example of a neural network that's presented these handwritten digits, and you see very nicely how it activates the different neurons in the layers until at the very end, it outputs and activates one single neuron that basically says that's the class 5, that's a class 5, in order to say what is encoded in the image. But why now? Why today? Why 2018? Why not 1960s? As I said, artificial neural networks are older than me. Why today? Well, the answer is twofold. First of all, we have far more data at our disposal than in the decades before. We get all these funny cat videos that we can classify. We have all the images that consumers upload. The platforms in particular, the GAFAs of this world, are at an abundance of data that they're sitting at, and that's semi-structured. That's fantastic for machine learning, far more data than in the decades before. Number 2 is processing power, Moore's law, essentially. So basically, what ironically has been developed in the last 15 years is so-called graphic processing units that are meant for computer gaming, for video gaming in particular, because they map very neatly and efficiently 2D linear algebra problems into a very efficient domain and then solve them very, very efficiently, basically, in a very parallel way. And this is exploited by the machine learning community, even though misused for the original purpose, but actually applied onto machine learning. And this is the reason why all of a sudden we actually have the means to process all that big data. We weren't be able to process that earlier. And that's why we can train much larger networks. Plus, a nice property of neural networks is that the more data you present to them and the bigger you make them, they actually improve in accuracy. Given that you can actually process it in terms of computation power, but that's a very interesting and also a new aspect of neural networks. So the big question is, what does that mean for us? It stands to reason that AI is digitization on steroids. In 2011, Mark Andreessen, a world-renowned now VC, said that software is eating the world. What he meant is that software is, or digitization is eating up every aspect of our life and our world. So everything, every process, every product, every good is somehow either built out of digital means or with digital tools. And this is a very, very strong statement, and it holds very, very true, right? 7 years later, even though. But the problem is that software is fucking hard. It's complex. Just look at that. I present you quicksort. It's a Java algorithm in this case that just sorts numbers in an ascending order. Very simple. Every child could do that. But that's fucking hard, right? Even if you're a developer, it takes you 30 minutes, if not an hour, to understand what's going on in here. Even imagine there's an error in there, like in row number 13, the Y should be a J or so, right? It's incredibly hard. And now think of it, this is a simple example, if you look at code bases from Google and Facebook, that are billions rows of code, right? They're incredibly large. If you would print them out and burn them on, DVDs, they'll probably get a staircase all the way to the moon. Who in the world is supposed to manage that? As a matter of fact, you need armies of developers, and software very much looks like that. It's entirely kind of crazy complex. But the good thing is, with machine learning, it becomes that. Because you can boil down a lot of your, in particular, data processing onto a very simple trained machine. And that's why software may eat the world, but AI eats software. That's why AI, or machine learning in particular, is digitization on steroids. We have no other means to survive, to be honest. Because if you look at how much data this planet generates, it's growing exponentially year over year. If by any means we want to make sense of that data that we generate, no developer army in the world could do that. We need artificial intelligence, or machine learning in particular, to make sense of that data that we generate. And if you want to take one piece of advice with you, then this is this slide, actually. This slide is fundamental. Every digital product, actually every product in the world, be it in automotive, be it in a SaaS business, be it, if you're an SEO, if you're an agency, the fundamental principle of any digitally enabled business is that. It's the tripod of user, data, and product. Imagine you build a product that's really cool, and you attract users, right? So you get to use it, and start using your product on your website, for example, and they generate data, tracking data. And this particular data is then fed back by you into the product because you learn from your users, you improve your product, because you're looking at analytics, you're doing BI, or you do even regression testing or A/B testing, if you're okay, right? Then you do that. That's great. That's cool. But in the days of AI, imagine you're adding a really smart recommendation engine to your product, then this cycle gets 10 times faster. The recommendation engine improves your product enormously. That attracts far more users because you're much better than the pack, than your competition. That, again, generates more data, and that, again, accelerates this whole cycle. This is super, super important if you think of AI-enabled businesses. That's why there are entire private equity funds just acquiring companies that have a certain data asset but don't know really how to do it, put a couple of data engineers on top of it and make it a multi-million-dollar business. This is the reason, that's the fundamental core concept of, I would argue, every business in the world, and you need to understand where you stand in that particular cycle, what arrow you're driving, and what's your impact on the business, and by that, the value of your role. So what does that mean for the GAFAs, Google, Amazon, Facebook, Apple, Microsoft, SAP, etc.? Well, basically, they're sitting on fantastic silos of data. It's a treasure. And I would argue that they haven't hardly digged up all the potential that's in that data yet. So if you recall this cycle that you can improve, in order to improve your product, and by that, basically grow your business, this is essentially what they need to do. 90% of all artificial intelligence applications in the world are actually to improve the existing business. It's a huge misconception that machine learning is creating huge new applications. It's actually not true. Speech recognition and image recognition, voice, etc., that it's been around since, the 70s. It's not new. It just got better. That's really the difference. It's about optimization. And that's why it's like a disruptive or enabling layer that's getting through every single piece of software in the companies, improving the software that is already there. So that's an important understanding of why Google and Amazon, they've invested so heavily in machine learning. Now, what does that mean for us? Well, are we going to be jobless in a couple of years? Maybe. I have to admit, as marketeers, we are partially an endangered species. After all, I think Zalando fired 250 marketeers last week or 2 weeks ago, I don't know. I have to admit, I found that quite surprising because I think what they said is they had these people let go, unfortunately, because AI is going to replace their tasks. And I found that quite puzzling. Because what I would do is I would first build the AI and then fire the people, but not the other way around. So, interestingly. Anyway, so looking at this particular survey done last year, that's a fantastic survey. Basically, what they did is they asked within the machine learning research community what the researchers think when a particular job profile is going to be replaced by AI entirely. What's interesting is that the discrepancy between the answers, the bars, the black bars, is very, very high. The variance within the data is very, very high. But only if you look at the means, the bubbles, the bullets, then you already see that, for example, writing a high school essay will be replaced in the time of 10 years approximately, telephone banking and a little bit less. And that's interesting because so probably start thinking, okay, what does that mean for me as marketeer, right? If I'm an SEO or if an SAA, well, the interesting and the good, there's actually two answers to it. There's good news and there's bad news. The good news is we are still in the decade of narrow AI. The AI or the machine learning algorithms that we train are very, very specific to a very, very specific task, right? We may be able to win Go, the game Go, but we will not be able to play with the same machine checkers. Right? So here, in this particular example, I tried to map out my skills on the x-axis with this little grayish bars. And I'm definitely not a world champion in all these tasks. And some I'm above average, though, better than the rest. But I'm certainly not the world champion. Now, if there are two skills that can be replaced by artificial intelligence, this is how it looks. It will be superhuman performance, right? It will outperform me and even the world champion, 100 times. Because usually the AI, which is often then trained against each other, is basically outperforming me. But the good thing is, and that's the good news, there's still a lot of other bars where I'm pretty good at, and AI or machine learning isn't it. So what does that mean for us? Well, basically, if you think of your skills as a bowl, then you can map your skills and your tasks, especially in your professional life, somewhere within this bowl, and you're jumping around in this bowl. And some of these parts are actually already AI-ified or machine learning-ified, so they are replaced and are very likely to be replaced very soon. But the good thing is, it's not, as I pointed out earlier, not everything. However, the question that you need to ask yourself in order to answer the question, how much of an endangered species am I, is, first of all, how digitized is my environment? As marketeers, especially as online marketeers, I would argue, it's pretty digitized. It's pretty digitized. You're staring at screens all the time, which is okay, which is a modern way of working, but hey, it's pretty digitized. So that means there is no medium, that's already in the right medium, right? So AI, already you are working in a digitalized environment. Second, how data-driven are you in your work? Are you doing work where you basically drive decisions based on data? And if you're driving decisions based on data that's readily available, then an AI could do the same thing very easily, in particular if it's repetitive. If it's repetitive, then it's actually kind of inefficient that you're doing that all the time. So it makes sense to build a machine learning algorithm that just does that for you. And in order if it's repetitive. Otherwise, if it's constantly changing, then I can't retrain a machine learning algorithm all the time. Does it require creativity in different domains? Do I have to pick up the phone while I book a flight or a cruise and have a client writing an email, chatting on WhatsApp, et cetera, being creative, drawing pictures? Does it require me to solve problems all the time, every day new? Then it's less of a danger. Because, again, AI is very narrow. How many others are there like me? If there's an army of people doing the exact same thing like me, the cost-saving potential of replacing this army is super high, such that it would justify a higher investment into replacing you as an army by machine learning. Or, and that's again something, if you have to abstract quite a bit, if you have to interpret quite a bit, that's less risky for you, because again, there you can do a very particular task very well with machine learning, but not go beyond. So the whole fear of this Skynet Terminator setting that is proclaimed by gentlemen like Elon Musk is just bullshit. Don't be afraid that in 30 or 40 years, Terminators will run and ruin and rule the world. That's just idiotic. It's not going to happen. We are far not there yet. We don't have the means of training a general intelligence that does that. Then, plus, it stands to reason whether at all the motivation of these machines is supposed to be negative or against humanity. There are reasons that it could be, but it's a kind of egoistic view in the world that where we project our view onto them. So it's idiotic. There are far greater dangers in the world, such as, global warming, where we should direct our attention to. And the reason is because, as I said, machine learning is kind of a one-trick pony. It can do one thing very, very well, but beyond that, once you train it, transferring it onto something else is hard. However, even though there is this one domain it's very good at, within this domain, it's amazing what it can do. One example that still, rushes me or makes me feel uncomfortably, it's scary, but at the same time, it's fascinating, is the Go championship between AlphaGo and Lee Sedol. Who has been seen it? I don't know, show hands, has been seen it? In 2016, it was fantastic. So it basically was a 5-match championship between AlphaGo, which is an AI algorithm, or basically a machine learning algorithm trained by DeepMind, a subsidiary of Google at that time, and Lee Sedol, the world champion, the universe champion of Go. Go is an Asian game, which you need to understand has more valid moves than the universe has atoms. That means you can't write a program, a static program, a rule-based program that just computes ahead a couple of moves and then retracts and say, okay, I guess this move makes most sense. What you have to do is to develop an intuition. You have to build up something that really plays as smart as a human in order to really win a game. It's far too complex to be, in the old AI world. Interestingly, it has been in the second game, it was 1.5 hours down the game. Basically, everything was still open. The first game, Lee Sedol lost incredibly. But the second game of 5, it was still open, so he still had a chance to win. And on move 37 was AlphaGo's move. It placed a move, and everybody in the room was puzzled. Nobody understood what's going on. Lee Sedol got up, left the room, came back 20 minutes later, and knew he lost. He looked at the board, and he saw the same thing like the machine, but he couldn't make heads or tail out of it. He knew that the machine knows something that he doesn't. It sees beyond his human capability. Obviously, he lost the game 1 hour later. And it took even the moderators, the world community, a couple of minutes in order to understand what's been going on in there, actually. It was a fantastic move that nobody anticipated. The machine learning algorithm, AlphaGo, played on a level that was far beyond the world champion. And that's scary because it also requires an intuition to play the game. It's a certain degree of creativity in that very narrow domain. It cannot play checkers, but it can play Go very well. And that's quite scary. So whenever you realize somebody is working on your particular job, on one particular task with machine learning, very likely you're going to be replaced. Interestingly, why does it got so bad, so good? Because they trained the machine learning algorithms against each other, right? They first trained them basically on a world championship level, but once they realized, okay, this is as good as it gets, they started training it against a different instance, a copy of itself, and that's how it got better. And this also sometimes is called these adversarial networks, where you can have other networks adversarial to the others. It's also very, very great for generating images. So, but let's come back to us. How can we tap into the potential of machine learning? As a matter of fact, machine learning is a commodity. The algorithms are free. It's public domain. It's open source. You can download it on your computer, you can use it. World scale, Facebook scale, Google scale algorithms. It's open source. The algorithms are open source. What's valuable are the data. The data that you need in order to train these models, that is exclusive. But that also means if you got a data treasure in your company, in whatever you're doing, then there's a very good reason that you have a competitive advantage because you can train a machine learning algorithm. And it's actually not that difficult. It's a huge buzzword, but it's not that hard, right? I mean, you are already working in a very digitized environment, so it's not that hard. So, how to get started? Basically, maybe as a byproduct, all the big platforms are providing machine learning algorithms as a service to consumers or small businesses as well. That's great, because if I'm Google, then obviously, and I'm developing that stuff anyways, and I'll open it to the others because it's, first of all, it's for those who want to do it, they can do it because it's open source, but those who still struggle with it, I can have a user-friendly or consumer-friendly version of my machine learning algorithm, plus I get the data. Right? I see how they use my system, my machine learning algorithm, and I can improve on that. So it's not a surprise that there is a myriad of different AI as a services around there which you can use. And they're not that expensive and not difficult to use. It's really, really handy. So looking a little bit beyond what we've been doing so far is that if we look at applications that are actually now possible because machine learning improved the way the data processing works to an accuracy level such that these applications become possible. In particular, what comes to mind are voice assistants, right? Speech recognition got much more reliable, much more accurate. Second, augmented reality, right? Taking a picture and having an overlay provided by the machine. It's also something that, because of computer vision, now we're able to do that. But the way how I look at it is, I don't see a big difference, because machine learning is, in particular, deep learning networks are very, very good at they're very, very good at processing natural data. Natural data is data that's where the origin is us, the nature, data that has a lot of noise in the signal, but also a lot of redundancy in the signal, statistically. So this is basically, for me, artificial intelligence is basically a processing machine for nowadays for bridging the gap between the communication of the machine and the human and making the distance of them between them less and smaller. And why you make them smaller? Because you are interacting better with a machine or with a higher bandwidth. Well, let me explain basically the higher bandwidth. You're speaking to a machine, you're looking at it with a machine, and you're providing it what you see. You provide far more data than with all these little altruistic ways of typing and using a mouse and a pointer. Because a voice, like a spoken word, conveys so much more information than just the word. It's a pitch, it's a tone, it's the frequency. There's far more going on than just the word. And this is additional information that the machine can use now. The same applies if you show around, if you show the computer what you see or what you're interested in at the moment in augmented reality. So it's actually quite the same, and this higher bandwidth allows us marketeers to tap, to enable us basically look into far more different ways of marketing our brand. But, and that I find actually more important, it allows us to understand the user much better because we get so much more data, so much more intimate data. We understand the mood that they're in. We understand the mood of the people they're in. In the example of the furniture augmented reality apps, there you understand how the people live, where they live, what colors they use, etc. So in order to understand the customers, it's great. Obviously, for advertisers, and if it comes to how to exploit that, this is still to be seen how this works. So this is basically my point. And for example, one particular fact that struck me was that Google released these earbuds, these Pixel earbuds, right? So basically, you would have an ear, plug in your ear, and it's basically a headphone, and you would hear what the others, what you hear is your surrounding, but you would also be able to translate the words or the sentences of somebody else speaking to you and have that overlay the reality. So for me, augmented reality is not just a vision thing, it's also an audio thing. Because in audio, you can also overlay and translate, like in Star Trek or in Babelfish. So that's an important differentiation there as well. Now, when it comes to SEO, Lansile is also an SEO company, and we really wrap our head around and try to think of how we can make sure that Google understands the value of our content. Well, to be honest, for us, in a general sense, I think you have heard it a million times, SEO becomes more and more a product discipline, right? Because in the end, we want to deliver a great product to our users and just help Google to improve their search in order to guide them to our product, which answers the question for them, ideally. But beyond that, in order to try to understand, what we're looking at is quite a bit at, we always thought of how can we reverse engineer Google to some degree. What would Google do? That's a question that we asked ourselves quite often. What would Google do if it would look at our site, at our particular URL or at a particular keyword? What would Google do? What does the market look like, etc. And in order to quantify that, you can do that very, very nicely with machine learning. You can try to for examples, I'm not saying that we've been doing that, but in order to, for example, to understand what keywords are potentially valuable because the market environment isn't so competitive, you need to first of all find these keywords, but then you need machine learning in order to investigate and understand and rank all these keywords that you have for market potential. Right? That's a fantastic use of machine learning. What you also need to understand if you only look at Google is that I'm strongly convinced that Google, if it's not already the case, does not know anymore how the ranking algorithm actually works, because it's all machine learning. It's a huge black box. There are probably certain rules that still apply, but when it comes to certain nitty-gritty things, machines can do this job much, much better than any rule-based system. So I'm convinced that by now, there is a lot of stuff going on that nobody can actually answer. It's been always Google's been always been a black box for us, but I think for them it's getting a black box for them as well now. But obviously, the result will be improved. The accuracy will become better. The precision, the recall will be much, much better. So, and how do you react as an SEO to that? I think you need to gear up. You have to gear up. First of all, you need to make use of tools that dramatically increase the scope of your vision onto the market, right? There are plenty of tools out there. I'm not going to advertise them, but you know which I'm talking of. So you first of all need to ramp up and try to get to an even level like Google, at least in your small domain, and have at least a similar set of data available. Market data, ranking data, stuff like that. Then you somehow need to be able to understand, okay, what would Google do and how would Google build a ranking algorithm? What would be important? Then you may try to understand how the Google user behaves and have that also influence the machine learning algorithms that you use in order to decide your SEO decisions. So there is a lot of machine learning going on, and there is actually a session afterwards where I may shed some light on that as well in addition. So for SEA, well, to be honest, I don't think that the classical keyword management and account building, et cetera, bannering, I don't think this will go on for very long, because machine learning can manage, optimize, run entire accounts much better. The good thing is, the platforms it's in their very best interest to provide you with these tools. So that's why they're heavily investing into that. If you want to know what's going on with machine learning in the next 1-2 years, check out the product roadmaps of Google, Facebook, etc., and you will see how much machine learning is actually on them. And you will see where they think they can actually provide superhuman performance and basically replace the account manager or the whatever manager in there. Also, when it comes to branding, I have a hard time understanding why there are still so many people actually drawing banners, right? They draw banners with Photoshop and stuff. With artificial neural networks, you can draw beautiful, perfect pictures and banners that are probably far better targeted. You can draw in the moment, if you think of a real-time bidding environment, you can draw the banner at the moment of the impression. That perfectly targets the mood, the time, the location, the weather condition, everything. Right? It's banner per PI. Think of that. It's doable. It's not even difficult. So all I'm saying is the tools will become far more powerful. And if you're an SAA to a large degree, you need to understand whether you're steering the lorry, right? How you can make sure that you're still in control of all these tools and just not be replaced by one of these. So coming back to my earlier statement of artificial intelligence is very much like teenage sex. everybody talks about it, nobody knows how to do it. My hope is actually that I was able to shed some light on this particular topic in the last 40 minutes. And where this is coming from, as a matter of fact, is from Hacker News. I found that on my way from the airport to the venue yesterday, and so I sneaked that in, my slideshow. And I also found a particular comment to that, which says some people are really doing it, but they're not doing it properly. So some of them will get better at it, and some will realize they started doing it way too early. But in a few years, though, most people were doing it, and it will be great. But they always exaggerate about it. And I think this analogy holds true. And I hope that you guys can start doing it right, have a great time with it, and improve your business. Thank you very much.
So many thanks, Johannes. A super exciting and passionate presentation. And usually I'm asking any questions, but as we are such a big crowd over here, I just look on my Slido and maybe I'm starting with the first question from the audience. And so one question was, do you think that Zalando made the right choice focusing on AI? And in your opinion, are they going swift the online marketing like they did maybe before when they started with SEO and all this stuff?
So basically, it's composed of two questions. First of all, was that is Zalando heading in the right direction? Second,
are they going to change the landscape in terms of online marketing like they maybe did 10 years ago?
So first of all, in order to survive, a cutthroat environment like that it is at the moment, it's very capitalistic in the online marketing space. Yes, you need to automate whatever you can automate, and you need to be as efficient as possible. So generally, I think, yes, everybody needs to do that, and I strongly advise everybody to take Zalando as an example in their very, very consequent and very very intensive way of building up a digital know-how base, base of very, very smart developers, be it machine learners, but also data scientists, etc. So yes, I think in order to stay competitive, that's necessary. Will they provide a platform? Yes, I think. Well, that's speculation. I haven't talked to the guys lately. I know them a little bit, but not good enough in order to answer that question bluntly. But it's very sensible to build the operating system for fashion, right? If you are building up a stack, a vertical into fashion, then you always try to find ways of monetizing it differently, right? Be it your logistics, your warehousing, other ways. So it's quite reasonable to, if you're very good in one particular vertical, to make it public to the others and somehow earn with it. Plus, it helps you to basically enforce your market position, your platform position. So I think this is a very reasonable step to open up the platform in order to strategically help others to make use of that platform, in their particular niche, but it also enforces their market position.
Thanks. And so I have a couple of other questions. The next one is very SEO related, however, as well on AI. So the whole topic of natural language generation. And it's always kind of interesting thing because I think around 8 years ago there were some tools, content spinners, which isn't really AI, which was maybe very simple stuff. But
it's in the large AI bubble, which is.
But now we're coming to a stage where maybe natural language generation leads to a real boost in SEO performance because we say, well, we just have automated text over there, or you think, no, this is not going to work.
I think that Google will become much smarter in detecting, oh, that's actually meaningful text or not. I think in the end, it doesn't matter so much how the text was created. After all, we're using Word and other word processing tools that already help us, in spell checking and style checking and stuff like that in order to get our message across. So essentially, it doesn't really matter how this text was generated as long as it is meaningful. So because we're talking about SEO. So I think what if I were a search engine, then I would probably try to train a machine learning algorithm that that doesn't really care whether this text was artificially created or however it was created, but what's the meaning of it? Does it really convey something sensible? Is it unique? Is it does it have a value in its own? And so I think the tools that we see at the moment, also at Axel Springer, there's this huge robo-journalism going on, where very local football results have been basically automatically published in numerous languages. That actually is valuable, and that really works. So yes, I think that's a tool you really should look at. Again, the software, there's plenty of options out there, but you need very good training data. And just training it on the Wikipedia may not cut it. So you have to be a little more nifty. But the good thing is there's plenty of text out there so you can train your models. So yes, I would definitely pursue that.
So, and maybe to continue on this question, yes, it's possible with probably good structured data and in a simple way like football games, and etc. Is there, I'm not sure whether this adapts, but there's a Turing test out there.
Yeah.
In terms of chatbots, could you apply this as well to natural language generation to say, well, in maybe a couple of years, there will be a text on artificial intelligence, and you as an expert, you can't decide whether this is written by an expert or by a machine.
Yeah.
Or not possible.
I'm pretty sure that there is more automatically written text already out there than you think. So, for example, if you look at Ladenzeile adverts, then especially in the Eastern European countries, they are pretty much generated, and they work very well. So there is a lot of generated text already that works really, really well. So in terms of, the Turing test is actually about fooling, right? So the Turing test says that will the machine fool a human that in believing that this is actually a human I'm talking to? It's questionable whether the whole Turing test is actually reasonable, because once you've been fooled, there is no value in realizing, oh yeah, I've been fooled. The question is what can we make out of it, and why how could that help us? Because if you look at chatbots, for example, they're crappy. They're entirely bullshit. But that's not because the generation part is bad, but because natural language or the machine learning algorithms are not good at understanding semantics. So as long as we don't understand semantics and actually can generate a conversation, a meaningful conversation, with the signals over time and react over time without knowing what will happen in 5 minutes, that's a very different story to just providing data on spot, write it once, show it everywhere. That's very different to when it comes to Turing, because Turing test is actually a little bit more about conversation. So yeah, in order to answer the question, I think that we will see better. I'm pretty much convinced that we'll see a lot of generated text, as we'll see generated images, graphs, etc., diagrams automatically, and also we'll see much better chatbots for narrow domains, but not for on a level like your mother, for example.
And so another question, I know there are some, where's Austria? There's Austria, there's somebody from Austria. You said that data is so important, yeah. And it's not so much about the algorithms, because they are open source, you can access all these platforms, however, the key is data. And in terms of SEO, one of the determining factors is always, was the user successful or not? And you could imagine that it's much easier for Google in US to say, oh yeah, he was successful, rather than maybe a smaller proportion of data, which Google is maybe having in Austria, where they say, well, maybe there's a cultural difference and people like other stuff. So will SEO be different from country to country, or is this just a stupid idea?
No, it's not a stupid idea. I think it will even be different. It's an interesting question, because what machine learning will enable any search engine to be very highly adaptive to even consumers. And SEO per country somehow implies that users see the same thing within that country. That's not going to happen. It will be highly individualized and highly, we probably need to think of SEO per person in a way, right? Or as it's already happening per keyword. So, and this is going to increase even more and become more important, because the decision-making of what's accurate or what's helpful for whom, at which point in time, according to which context of a query and which search history or search session, that's will going to be very, very, very impactful in recommending. So yes, there will be less data. It's also called a sparse data problem. But also, there is less content to rank, often, right? So plus, you have means of, it's called transfer learning. It's a little bit misleading, but you can to some degree, pre-initialize a model, like a neural network, train it on a very, very strong corpus, and move it over as it is, and then continue to train it onto, let's say, an Austrian corpus. There are ways you could actually somehow get rid of this that particular sparse data problem. Plus, you could also try to buy data, right? Often, if you have quality raters or if you have people manually annotating search results, then that's a fantastic ground truth training data as well. So it's a question of money, but it's doable. It's a solvable problem.
Yeah, super. And I have a final question before we go into the coffee break. And I will adapt it a little bit to my world, because the question was, what recommendation would you give a kid of age 6? So my kids are 12 and 14, and they may be more open now to advice, maybe not, I'm not sure. And the question was, what recommendation would you give a kid of age maybe 12 or 14 to be ready for the upcoming AI, deep learning world? So should now my kids focus on mathematics very early, or they should go for learning French, English, and Latin?
I believe it's, as I said earlier, machine learning is digitization on steroids. So whenever your kid is interested, or you try to get your kid being educated in the digital world, it's already a very, very important step. I'd say this is the most important step, because a lot of the stuff that's happening with the machine learning world is actually an analogy, or it's just like very linearly leading out of the digitization, right? You would just have an algorithm, now replace it with a different algorithm, etc. It's not that different. So I would say I would not pain too much a kid about trying to explain why Netflix is, rating or ranking this particular movie there and that. It's very intuitive, and for us as a user, it doesn't make, just by using it, not make much of a difference whether the result is great because it's manual, or the result is great because it's a rule-based system, or because the result is great because it's a machine learning algorithm in the back. But what is important first is to get the basics for a kid to understand in digitization, and then I would probably, once it starts digging deeper, ask for microcontrollers and how does the electronics work and the inner workings. Then I would probably try to, teach them some math. It's all about statistics, it's true, but it's like Lego, right? You would start with small and large Lego bricks, and you would keep the Lego technique for, I don't know, until they're 14 or 16 or so.
Super. So thanks very much again, Johannes, for a very passionate and exciting presentation.
Thank you very much.
Thanks. Super.
Thank you very much.